Let's go over number 13 of the SOA sample questions for exam P. So let's go ahead and read the question first. An actuary is studying the prevalence of three health risk factors denoted by A, B, and C within a population of women. For each of the three factors, the probability is zero point 0.1 that a woman in the population has only this risk factors and no others. For any two of the three factors, the probability is 0.12 that she has exactly two risk factors, but not the other, meaning not all three, so only two. The probability that a woman has all three risk factors, given that she has A and B, is 1/3. What is the probability that a woman has none of the three risk factors, given that she does not have risk factor A? So this is really a Venn diagram problem, so I'm going to draw a box that denotes that within this box, 100% of the population lives within this box. And then I'm going to draw three circles for A, B, and C. Okay, so this is A, this is B, and this is C. And let's start filling out this Venn diagram. So we know for each of the three factors, the probability is 0.1 that a woman only has one of the risk factors, right? So that means here it'll be 0.1, 0.1 here as well, and here as well. Now, the next piece of information that is that for any two of the three factors, the probability is 0.12 that they have only two risk factors, but not all three, right? So that means in this intersection, it'll be 0.12 here as well, and here as well. Now, the final part of this is that the probability that a woman has all three risk factors, given that she has A and B, is 1/3. So this last sentence doesn't actually give us the actual information of what this final intersection where all three circles are intersecting, but it does give us enough information to actually solve the problem. So I'm going to call this X, and anything outside of these circles, I'm going to call Y. Okay? Now, the first thing we have to do is solve for X. And it's actually pretty simple. So we're given that the probability that a woman has all three risk factors, right? So we're going to go X given. So this word given means that we're going to divide by the subpopulation. So basically what it means is that X is the subpopulation, and this given is the subpopulation. So given that she has A and B, so given that she has A and B means that she has at least two risk factors, maybe three, but we don't know. So it could be that she has two factors or she has three factors, but they're all included within the denominator. So we're going to do 0.12 plus X, right? Because all of this population and this population are included with this subpopulation. And this probability is equal to 1/3. So with this, let's just do some algebra. So we know that 3x is equal to 0.12 plus x. So that means 2x is equal to 0.12. That means x is equal to 0.06. So that means this intersection where all three risk factors converge or intersect is going to be 0.06. Now, if we add up all of these Venn diagrams together, what would that number be? So let's just do some addition. So 0.1 times 3 plus 3 times 0.12, because we have three different 0.12s, plus 0.06 is equal to 0.72. So now let's look for y, because that is what we want to find. So what is the probability that a woman has none of these three risk factors, given that she does not have risk factor A? Right, so first we need to find y, because y is none of these risk factors. So this is what y is. So y is going to be equal to the complement of A, B, and C. So that means it's going to be 1 minus all of these different circles added together, right? So y is equal to 1 minus 0.72, which is equal to 0.28. Okay, well, we're almost done, because you have to remember that the question said given that she does not have risk factor A, right? So what is risk factor A? So A is going to be the addition of 0.1 plus 0.12 plus 0.12 plus, you have to remember the intersection where all three risk factors are included, and that's going to equal 0.4. Okay, so now we have all the information we need in order to finally solve this problem. So it's going to be y divided by 1 minus 0.4. So y is the probability that a woman has none of the risk factors, divided by the fact that, or given that this woman does not have the risk factor A at all. So there's no possibility of having the risk factor A. So this is going to be 0.28 divided by 0.6, which is equal to 0.467. Okay, and so that's going to be our answer, and it's going to be answer C. So from when I took exam P, this sort of really felt like a question that would really appear on the exam, because it's, even though it has basic probability, they kind of add twists and turns to the question, such as like the last sentence of the first paragraph, where they're saying that the probability that a woman has all three risk factors, given that she has A and B, and things like the actual question, what's the probability that a woman has none of the three risk factors, given that she does not have risk factor A. So that word given you should already in your mind be thinking about, okay, so given means that I'm going to have to deal with the subpopulation, and so that subpopulation is going to be the denominator. That's how I would think about it. It may I think that's a good rule of thumb to go by, but obviously each question is very different from each other. So you have to really read the question and understand what the question is asking for. Okay, well, that's going to do it for this video. If you like the explanation and just kind of like the methodology I used, or if it was easy to understand, please leave a like. If you have any questions or comments, leave a comment, and I'll catch you in the next video. All right, thanks.